Hey, welcome back. We're going to review a little bit for the quiz you got going on tomorrow. So I just want to go over a couple things that I want you to remember, okay? And then I'll send a copy of this notes always. But as far as if something is proportional, it has to have a constant of proportionality, okay? So for proportional, I know we did this once already, but remember that you have to have a K. K is your constant of proportionality. Okay. K is always equal to y over x, not x over y. So your constant proportionality is always your y over x. Your equation is always y equals k times x. Okay? So those are the three things definitely that help you find k or to help you write the equation if you know your constant of proportionality. If it's a table, make sure that all of your y over x's are the same. So if I had a table like XY table, okay, it could be distance, time, doesn't matter. All of my y over x's have to be the same. Otherwise, it's not proportional. So if this is 0, 0, okay? If this is 5 and this is 10 and this is 15 and this is 30, my 0, 0 is not going to count, and you can't use the 0, 0 because you can't divide by 0. But I would check every other one. Is 10 over 5 equal to 30 over 15, okay? And every other one down there, they all have to be reduced to the same thing. And then for graphs, okay, again, all my y over x's are going to be the same, and it must go through the point 0, 0. Must be a straight line. And must go through the point 0, 0. Okay, so those are the things you got to keep in mind for constant of proportionality and if things are proportional or not proportional. Okay, the other thing I want to do is go over a couple of the homework problems that I noticed people were having issues on. So I picked out a couple of them that a lot of people got wrong. I just got to remember which ones they are right now. Oh, the other thing on here, remember, I'm sorry, I'm going to go back to the equation part. It can't have a plus or minus anything, okay? So if I had something like y equals kx plus a constant, okay, that is not proportional. You can't have a plus or minus right there, all right? All right, so in lesson 11, I think was the one. I'm going to show you kind of on the homework that I saw a lot of people getting wrong. Number 1 was one of them. Okay, so when I went through the homework and checked it all, here's one of the things that I was seeing. Wrong page there, okay? All right, so this one says there's a proportional relationship between the number of months a person has had a streaming movie subscription and the total amount of money they have paid for the subscription. The cost for 6 months is $47.98, okay? So they've done the point $47.98. To find the constant of proportionality on here, I've got to do y over x, which would be 47.94, not 98, divided by 6. When I divided that out, I got $7.99. Okay, one month. So my constant of proportionality was 7.99. Okay? Pretty sure I got $7.99. I should look when I divided it out. All right, so that was the first part of that one. The second part of this problem says, what does the constant of proportionality tell us about the situation? It means that it cost $7.99 per month. Okay? So the cost is equal to $7.99 each month. Okay, what changes, so this, my cost is going to be my dependent variable. What changed my independent is going to be the number of months. So if I had 2 months, it'd be double that. If I had 3 months, it'd be triple that. All right, add at least 3 more points on the graph. So if I added the 0.1799, I can't do it exact, okay, because this goes by tens. So I'd say that's about there, okay? And what I did to get some other points is I knew that this was the 0.1, okay? I did 10 because that's really easy to do. So I did 1079.90. So 1079.90 would be probably right below the 80. All I did is multiply both of these by 10, and then I doubled that one. I just did it the easy way. I could have doubled this and done 2 as well, but I doubled this, so I did 20, and that came out to 159.80. So all I did is times 10 by 2, where I do 20 for x, I times the y by 2, and I got 159.80. So I would do 20, 159.80. So whatever I do to the first number, I have to do to the second number because they're proportional. And if it is proportional, it would make a straight line, which this one hopefully will if I could draw straight. Okay. It's not going to be exact because that's not an exact point. That's not an exact point. Okay. I can't do an exact point with dollars and cents on here, but I can be really close. Okay. And then the last part says write an equation that represents the relationship between C, the cost, and M, the subscription. When I said, what did the constant of proportionality mean? It means the cost was equal to 7.99 times the number of months. So that would be my equation for this. Okay, so that was a question that a lot of people got wrong or got parts of it wrong. Because remember, this is my K, and it's in the y equals kx form. So I substitute that in, but they use C and M instead of y and x. Okay, so that was one of the ones. Another one that I saw a lot of people get wrong was number 4. What information do you need to write an equation? Yeah, need a constant of proportionality, okay? So I think that's all this was asking is you need to know the constant of proportionality. Proportionality. Okay, that was all that question was asking. Okay, I want to do a couple on number 12 too because there were some questions on number 12. Number 1 and number 2 was the biggest ones I saw. All right, most of you got this part right where it said volume and cost and volume in ounces. Okay, so it says one of the graphs shows cost in dollars versus drink volume, and one of the graphs shows calories versus drink volume. All right, so if I had to look at the graph and figure out which one it was, what I want to look at is the numbers, first of all. My guess is it's not going to cost me, this is for a coffee shop menu. My guess to look at the best thing is it's not going to cost me for 10, let's say, cups of coffee, $150. Or 10 ounces of coffee, not cups of coffee. 10 ounces of anything in a coffee shop probably isn't going to cost me $150. 10 ounces might cost me $375. So this one's reasonable. So this one I would say would be the cost. And then if I look at calories, I do know that 1 cup of coffee or 1 whatever, unless it's like a carrot, is not going to be, 10 of them is not going to be 3.75 calories. That doesn't make sense. So it's got to be this one, okay? And most of you got this part right. So which we did that one. What quantity appears to be proportional? These aren't exact. It's saying appears, and a lot of you said it's not proportional, and I totally agree with you that it doesn't totally line up, okay? But it's saying which appears to be proportional. This would never go through the 0.00. So the calorie versus volume one does. And I think that's what threw everybody off, is it's not exact. The points aren't exact on there, okay? Because you can't squeeze 50 in here. So it's not exact, but they are proportional. And then if I do know they are proportional, what's the constant of proportionality? I'm going to take the 2 points I do know and make sure they're the same. So if I did my y over x of 150 over 10, I get 15 over 1, okay? Also, if I did 360 over 24, okay, I'm going to get 15 over 1. So my constant of proportionality would be 15. That goes here. Because I took my 2 points and did y over x. And what does that mean? It means every, I lost my train of thought. Every 1 ounce of coffee is 15 calories. 1 ounce of coffee or coffee product or whatever it is. I'm going to say coffee. Is 15 calories. Okay. So that one I think a lot of people got wrong because it didn't line up, and I understand why you would think the way you did. All right, the other one I saw a problem with was this one. Lynn and Andre biked home from school at a steady pace. Lynn biked 1.5 kilometers and it took her 5 minutes. Andre biked 2 kilometers and it took him 8 minutes. Draw a graph with 2 lines, okay? So I'm going to try and draw a graph with 2 lines here. Oh, there comes Olaf. He's going to come in my picture in a second. Kitty, you need to move. All right, so if I'm looking at Lynn and I'm looking at Andre, okay? Lynn biked 1.5 kilometers in 5 minutes, okay? All right, so I would say that this would be my minutes and this would be my kilometers. I don't need the bottom part of this, so I'm just gonna, and this is kilometers. So if I do y over x, it's gonna be 5 over 1.5, which gives me 4. No, it doesn't. 1.5, 1.5. Oh, Andre's 4. Sorry, I'm looking at my information over here. So I'm doing kilometers over minutes. I wrote it wrong. Sorry. I'm doing y over x and I'm looking at the wrong thing. I'm like, that didn't look right. So sorry, I would do 1.5 my y over my x. Okay. And when I figure that out, I would get 0.3 kilometers for every 1 minute. Okay. So if I graphed Lynn, so let me scoot that up so you can see it. If I'm graphing Lynn, I'm saying, I'm going to make these by 1 kilometer, 2 kilometers, 3 kilometers, 1 minute, 2 minutes, 3 minutes, 4 minutes. Okay. So I'm going to graph Lynn. So for every 1, she goes 0.3. 2 would be 0.6. Okay. 3 would be 0.9. So that's going to be Lynn's line. It would look like that. All right, if I do Andre, it says it took Andre biked 2 kilometers and it took him 8 minutes. Okay, so if I do my y over x, I'm doing kilometers, which were 2 over 8 minutes, my x, which is, if I divide that out, it's 1/4 or 0.25 kilometers for every 1 minute. So if I'm doing Andre's, okay, Andre would be at 1 minute, he was at 0.25, so they're very close. 2 minutes, he would be at 0.5. 3 minutes, he would be at 0.75. 4 minutes, he would be at 1. So this would be Andre's line. Okay? And it said highlight the point with 1K, and that's what we did here. Okay? So Lynn's K was 0.3. And then, what's his name? Andre's was 0.25. And obviously Lynn was going faster because her graph is going up faster. So that was that problem. I think the other ones looked pretty good. On lesson 13, I haven't really looked at lesson 13 yet because I'm doing these a little bit ahead of time. Just make sure that it said, sorry, I'm on the wrong page again. So on this problem here, if I'm doing a graph, it says at a supermarket, You can fill your own honey beer container. A customer buys 12 ounces of honey for $5.40. Okay, now what this is trying to show you is that you can write this two ways. I could write how much per ounce, and I could also write how much honey I could get for $1. Okay, so there's two ways that I could do this. How much the cost would make more sense over here. That would be my thinking. And then the ounces I would think would be good over here. Okay. So I would have to figure out my K first because I want to know how much is 1 ounce. So if I did that, I'm trying to figure out, I've already done these ahead of time, so I'm trying to find my page I did. Okay. So if I did this, if I did my X over Y or Y over X, like I thought I said, I would do $5.40 for 12 ounces. Okay. Then I would just divide that out. When I divide it out, I get 0.45 cents for every 1 ounce. Okay. Then it wants me to do, well, okay, that was how much does it cost per ounce? Now it wants me to flip it and say, okay, well, how much can you buy with $1? So now my X and my Y's switch. Okay. So if I switch them, it would be, okay, I can buy 12 ounces for $5.40. I want to know how many ounces can I buy for $1. I only have $1 and I want to buy the ounces. Okay. So then I would do it the opposite. I would divide that out and I would get 2.2 repeating. Okay. Which is 2.9. So if I graphed this, okay, so they're both the same equation. My graphs would look totally different. I'm going to graph them both and show you what I mean, okay? So if this is ounces and this is cost, I'm saying, how do I want to do this? So let's say 50 cents, 0.50, $1, $1.50, $2. I'm just going to go by 50 cents, 1 ounce, 2 ounce, 3 ounce, 4 ounce, okay? So we said that 1 ounce costs 45 cents, really close to 50. 2 ounces would be 90 cents. 3 ounces would be $1.35. So it would look like this, okay? That would be my cost in ounces. If I wanted to do the other equation, now it's just asking you to do one, but I want to show you if you did it the other way, and I'll do it in purple so it's a little bit different. Let's say this was my cost and this was my ounces. Okay, so I would do it a little bit differently. I'd say for every $1 cost, it's 2.2 ounces. Okay, so even if I kept the same thing, this would be 2.2 would be like up here. $2 would give me 4.4, would be way up here. So my graph would go like this, okay, depending on how I numbered it. So it's just showing you that there are two different ways you can do this. On number 2, and I'm not going to go through all of them, it says the point 3/6 lies on the graph of a proportional relationship. Which of the following points also lie on the graph? The easiest way to do this is to figure out what your y over x is, okay? Because, or I could look at, it just depends. If I do 1 times 3, I'm going to get this, is 0.4 times 3 this, okay? Or I could set up a proportion. So this is my x, this is my y. So if I did y over x, 0.4 over 1, does that equal y over x? 6/5 over 3. Okay, so I would say, is 6/5 equal to 1.2? Which it is, so that one would be equal. So there's a couple ways you could do that. Set up a proportion, y over x has to equal y over x. If you cross reduce, this was 1.2. This is 1 1/5, which is 1.2. They're equal. Okay? All right, so hopefully that'll help you to get ready for the quiz. Take your time on it. Do it again if you don't do as well as you think you should. I really want you to learn it and do really well on it. If you have any questions, let me know, and I will talk to you all later. Have a good week.